Hey everyone, welcome back. So if you came to this third video hoping for some more dry, boring me talking lecture material on best practices and Java packages, well, prepare to be disappointed because in this video we're actually going to start coding stuff. I know it kind of took us a little bit to get into this, but I kind of rattle off a bit in the first few videos about some important little topics that are just good to know in general for when you're programming your game. So yeah, like I said, we're actually going to start digging into our project now. If you remember from last time, we set up a bunch of our basic configuration variables for how our app will look in its application window on the desktop, and we also just kind of generally talked about the render cycle of our apps and like how it gets processed. You know, this render method gets called 60 frames per second because we set our FPS and locked it there for the time being. And we also took a look at the desktop launcher and getting those settings configured in here in the LWJGL configuration, and that way we can just stay out of the desktop module from now on, and we can just stay working in this core module. So to start, I'm going to bring up a few small, like, minor modifications to the way we had this set up, because I realized I totally overlooked something when doing this. When you're making your app or your game, you essentially work in this virtual environment. You have a camera that pans around this environment, and you know, the game screen isn't really in respect to that environment that you're working in, because you can scale in and out. You can scale like everything up to where images are larger or smaller. You can pan around, you can change the scope, you know, everything. You can just modify the view that the player is getting. And with that, you will have to understand a concept that's a little hard for people to grasp to start. But I will kind of go over this once we start touching on viewports with our game screens. So just so you know, we are going to be touching on some of that Scene 2D stuff, but I have also decided we're going to mix in Box 2D with it. And so that's where things will get a little bit interesting, because in the previous project, all we did was Scene 2D. We used Scene 2D UI buttons, and we didn't really even get into table layouts or anything fancy like that. It was just a bunch of buttons that we moved around and just kind of made our own makeshift game like that. But this time around, we're going to have some UI using Scene 2D UI with some bitmap fonts. We're really going to hit all the bases here, and it's going to be a great learning experience for you guys, I'm sure. So to get back on topic, as I was saying, the minor modification I wanted to make is with this app width and app height, although on the desktop it is going to be representative of what we will be seeing as far as the application window goes. Also, I did change this from 480 to 420, so now it's a 720 by 420 window, and I just thought that was kind of, I don't know, it looked a little bit better to me as far as the widescreen goes for a nice arena for Pong to be played in. So you got a little bit more room for the ball to kind of navigate around. Anyway, I thought that would just be a little bit nicer, but that's personal preference. Again, this is more so for you to watch how I'm programming this and observe these features I'm implementing so you can use them in your game. You don't necessarily have to be making a Pong game. Like I said, a lot of these pieces can be plug and played anywhere else, the way we're going to be making it, so long as you build it that way. And that's why I really cover a lot of this stuff, this kind of high level understanding of why I'm designing things like this, so you guys can have a modular setup and almost like a skeleton project that you can always come back to and just start building off of that again. That way you can jump into a project quickly and have something to work with that's effective in your approach in designing your next new game. So yeah, like I was saying with the desktop viewport, it's just the application window. So this is a defined desktop window size, and so I'm just gonna kind of add app desktop width and app desktop height. So those are going to be just a defined width and height for the application window that we have. And so because we made that change, let's go back into our desktop launcher and respect those changes. Okay, and so that should be all good to go. And if I run it one more time, we won't get anything because I did remove that sprite batch and that image that we had, and we'll be adding that stuff again in a second. Also, one thing I don't think I talked about in the other videos, you'll see this warning down here. Maybe I did. I can't really recall. You don't have to worry about this. This is just LibGDX having not updated their OpenAL yet. They're getting there. I'm pretty sure it's supposed to be within the next update of LibGDX. So just ignore it for now. It doesn't really do anything bad for you guys. So anyway, so we got our nice application window and we're good to go. So we can close this desktop launcher and never really have to look into the desktop module again until we really need to configure stuff as far as running and getting those system specific configurations like vsync and whatnot set up down the road. So another thing, if you're working in IntelliJ, right up here in the top left, you'll notice I have packages highlighted. There's these double arrows here. If you click that, there's a few checkboxes. So there's the project, packages, project files, problems, production, tests, scratches. I don't know what scratches is, but I have used tests and production and project files and packages before. If you select the packages, that view is different for your project view. So you'll notice I select project, and that's strange. Let me re-render that. There we go. You'll notice I get all the extra Gradle and the compiled output folders and whatnot, and I see all these project, like IntelliJ project files. We don't really need to see that stuff like this get ignore. We shouldn't be seeing that within our workflow. So when you select the packages, that gives you a really concise view. As I said, you want to minimize what's going on over here so you can focus on what's important, and really just I'm trying to narrow down that view for you guys so you can't be overwhelmed by what you're working with. And so when you have packages selected, you'll be able to just see your core module, and then you can just condense all these other folders, just collapse them, and you should be good to go. So now that we're back on topic and in the code again, there's a few variables that I want to add. They're going to be, again, with respect to the viewport. So this is just to prepare us for down the road, but public, this is going to be our kind of game, or rather virtual, what is that? Virtual vars, I guess. I'll just call it game vars. Yeah, and so public static int, and I tend to call these v width. That's going to be 720, and then public static int v height, and that is going to be 420. So they are the same right now, but again, let's say you wanted your program to be a 1080p window, for a 1080p desktop. Well, your game will, using this virtual width and virtual height, your game will still run in a picture size relative to that width and height. So that's like your game space, and you can change this to like 1920 to 1080 for that 1080p resolution, but these would stay the same. So you're always working where your game is the actual, like, in the game world, you're working with respect to these numbers, but it gets scaled up for these numbers on the desktop. And we'll see that reflect later on, again, once we get into setting the viewport for our screens. And this is going to be a more, I'd say, fulfilling approach than we did in the slides game tutorial. So I hope you guys are ready to kind of work with that a little bit more hands-on and get some good understanding as to how to handle your windows a little bit better. So other than that, like I said, we want to break this down into the simplest elements. And before we really get into the game, we want to make sure we have some, a game that can start up and in the least. So we don't want to just kind of do that, just halfway. We want to make sure we set ourselves up right, so we don't have to do a lot of refactoring in the long run, because nobody likes to go back and touch old code. I mean, you do have to do it sometimes if you're making modifications, but that's another story. So we're gonna do it the right way to start. And what we want is we want some managers just to handle the high level functionality of our game, where they kind of manage the workings of like the flow of your game and when things happen and what things are happening. And with this class, we can just have this class coordinate those managers by getting them set up and telling them, okay, you can go on your way and run the game as you see fit, as you are programmed. And so that's us delegating these jobs to these managers. So like there'll be an audio manager, there'll be the game screen manager, there'll be the asset manager, and they'll have all their own pipelines that they'll concentrate on and set the flow for your game for you. And so you just tell them how they're programmed, and your game will be able to manage itself in that way and kind of work with all these pieces, but they'll stay within the scopes of what they're meant to do. And that's really good design as far as like getting your game set up. So I'm going to start with just at the top here, because we haven't made any of those manager classes yet. I'm just going to make a little comment here, and I'm going to just get the asset manager set up. And we don't really have any assets yet, but that's okay. And I'm just going to call this assets. And there's a quick reason why I made this public. First of all, we're going to be passing an instance of this main application class down to our game screen manager and our audio manager. That way they can reference the main application to be able to touch the assets and also just have access to like our main sprite batch, our main shape renderer. I feel like it might be good just to have those in our main game class just because it just makes it a little easier on our end. It's not necessarily bad design, because you don't want to be making a bunch of sprite batches everywhere anyway. They are kind of monsters of their own, so they should just be in this top level access area, just so that it can be accessed from within your game as far as the downward scope goes. So we have our assets, which is only public. That isn't going to be static, and the reason for that is a lot of people tend to use like public static asset manager assets on Android. That is bad, because static references to variables in classes, especially like this main kind of class, has potential to have memory leaks with those resources. So like if references get left behind on that asset manager, then it will get leaked, and you have a potential to leak context of the activity context on resources and whatnot. So you definitely don't want to have an asset manager static in any case ever. Anytime you're managing memory in any way, as far as like resources you're using, don't put it in a static context. So that's just rule of thumb. Don't do that. Big no-no. So with that, we also want to create our batches. I do know to start, we definitely want a sprite batch. We will have images sooner or later, so I'll just have that public batch available. And then we also want our shape renderer, because I might just use that until we get until we get actual images for you guys out. So we're just gonna use that for debugging until we find that what we've made is, reasonable, it's concrete, the game is looking good, and we can move forward in creating the graphics. As I said, you don't want to work on that until things are in place and they feel right. You want the game feel first, then the graphics. So we have some of these public variables set up now, and in the create method, or actually, first things first, we need to change this from application adapter to game. And game is used for the, oops, that is definitely not what we want. How do I, there we go. So game, okay, good, imported the right one. So now that we've set it to game, we're using the game class because that is a class that handles screens. It has its own kind of what is it? It manages like the showing and hiding of screens. It's got that whole flow for screens set up inside of it, so we don't have to program any of that ourselves. But we are going to be doing some interesting things as far as designing like an abstract screen, and how the game screen manager is going to look is going to be pretty unique compared to some of the other examples we've seen in the slide game, or maybe even other games you've seen made in LibGDX as well. It's just something I'm trying out this time, and so far from what I have working on my end, it's worked out pretty well, and it's been easy to work with and easy to manage. So hopefully it'll set you guys up in a good position as far as like in the long run once we start getting more into this game. So now that we have that figure it out, we have our application is extending game now. We need to initialize some of these things right here because they are public variables. We need to make sure they're made before we can use them anywhere. So this is going to be the place we want to look to. And so we have the asset manager. So I'll just create a method called init managers, and then we can just have a batch equals new sprite batch. I might not even have that init managers, honestly. Yeah, that's just kind of boilerplate stuff that we don't really need to introduce. So shape batch equals new shape renderer. Okay, good. And then our assets equals new asset manager. All right. So we have those three things all working right. And we have a quick change. So what I'm going to do is, ooh, that was a little too much. What I'm going to do is just comment these lines out for now. And I'm going to put a super call, and I'll explain this. So when I call super.render, now that this class is extending the class game, the super.render kind of makes this go over into the screen management mode. How how I was telling you how the game class manages screens primarily. The application manager or the application adapter doesn't. It's more for raw, like writing your own systems if you're not using screens. The game class was made so you can use screens effectively. They have it all set up themselves. And, you know, if it's provided to you, there's probably a reason it was provided to you. And that's just to get your games off the ground quick. And screens, you know, they're really actually a good approach. So we're going to use that same kind of setup in this, but again, it's going to be a little bit more advanced than we made in the slides game. So calling the super.render puts it into that game screen mode, and it will kind of use the render mode or render method a little bit differently than just having this public void render and then delegating like game screen manager update, game screen manager render, you know, that kind of stuff. So we'll see those changes reflect once we start making our game screen manager. We do want to save these calls because we still want to do our buffering on our screen by, you know, refreshing the screen every frame. And of course, I'm still going to keep my quick escape app exit code right here, just because that's something I like to have. And then next thing, we need to make sure we dispose of stuff. I'm sure in my previous videos you've all heard me say, make sure you're doing proper memory management. You want to be effective and efficient. So you got to make sure you're disposing of resources you're not using, letting go of them appropriately so you don't have memory leaks, and the garbage collector doesn't have to really throw its back just to take care of your game. So we need to, let me think of the order here real quick, because the order does indeed matter. We need to dispose of the batch and the shape batch, I'm pretty sure, yep. And then there's also the asset manager, which also has a dispose method. The asset manager isn't something I wrote. It is built into LibGDX, and it is a very effective asset manager, as we'll see used later on. So with that, I think we're looking pretty good so far in our main application class.